How many planets are there in the solar system? Well, some of you may remember about 20 years ago when this number came down from 9 to 8. That was because we found out Pluto wasn't actually a planet. It was too small to be considered one. So since then, we say that our solar system has 8 planets, then a whole bunch of asteroids all orbiting our sun. But beyond Neptune, the 8th planet, beyond all these asteroids, there's still a vast region that's unknown. And some scientists believe there might be a 9th planet still orbiting our sun, but far, far away. This is called the Planet X hypothesis. Now, this planet would be larger than Earth, but so far away that our chances of finding it at random just by pointing a telescope in the sky are almost 0. Even with our best telescopes, like the James Webb Space Telescope, it would be like looking for a needle on a haystack, almost impossible. Now, is there any chance to actually find this planet? I'm going to show you that we don't need to actually see a planet to know that it's there. And I'm going to start by making you think a little bit about dogs and cats. So imagine you live in a house in the middle of a field, and you have a dog. Let's call him Cooper. And then every night at 7 p.m., you send Cooper to run through the field, and he runs on a large circle around your house. And you send, Cooper, run! And he starts running the circle, and he's back, and you look at your clock, and it's exactly 2 minutes. Then the next day, he does the exact same thing. You send, run! And he runs, and you look at your clock, and it's 2 minutes. Always the same time, except for one situation. See, Cooper's not the only animal you have. You also have a cat. And if the cat is out there in the field while Cooper is running, Cooper's also going to chase the cat. Cooper chasing the cat is faster than your average Cooper. So he'll be back, and you'll look at your clock, and it's 1 minute, 30 seconds, and you'll know the cat is out there. Planets are not dogs or cats, but they also chase each other. And that's because they have gravity. The same way Earth attracts everything towards it, every other planet is attracting things in their direction. So you see how this can get complicated. You imagine every planet orbiting the sun, but at the same time, they get distracted, like Cooper and the cat, by the other planets. And this causes small displacements in their orbits, so the orbits are not perfect. So if Planet X is actually there, it will be pulling all the other planets. And looking at the other planets and asteroids, we can see if their orbits are the exact way we predicted them to be, or if they're a little bit to the side, which would be evidence to Planet X. Indeed, this was exactly how Neptune was discovered. See, 200 years ago, an astronomer was looking at the sky, and he was looking at Uranus. He expected Uranus to be somewhere in the sky at a specific time, and Uranus was late. He was like, why is this planet late? Except if something is pulling it back. So he did his math, and he predicted the exact position where this whatever was pulling it back would be in the sky. And he sent this out, and astronomers in Berlin pointed their telescopes, and there it was, Neptune, with nowhere left to hide. Now, if Neptune was already discovered this way, why haven't we found Planet X? The issue is, Neptune and Uranus are relatively close, so the gravitational interaction is strong. And you can see it only by looking at Uranus' orbit. Now, if Planet X exists, it's really, really far away from everything. It's 10 times further away from us than Pluto. So the gravitational force is weak. How can you see this in the orbits of anything? It's like really small, the displacements. Imagine an airplane that just crossed the Pacific, and you're trying to see if it displaced 1 inch to one side, or 1 inch to the other side. It's impossible. So you can have an idea of the numbers. An average main belt asteroid, that's an asteroid between Mars and Jupiter, would walk 2 billion miles on its orbit around the sun. And Planet X would displace it by 1 meter. 1 meter on front, 1 meter to the back, 1 meter to the sides. How can we even think on trying to find this? Well, our team here at the University of Pennsylvania is trying to bridge this gap and make the impossible possible. How can we do this? First of all, we can't look at only one orbit. In the case of Neptune, we're looking only at the orbit of Uranus, and that was enough. But our task is hard, so what do? We need to increase the workforce. So we plan on looking at 500,000 main belt asteroids. Remember, those asteroids between Mars and Jupiter. And if we're tracking 500,000 orbits and seeing the displacements in each one of them, then it's easier to find a pattern. It's way easier to see something's happening if you have 500,000 test cases than if you have only one. Second, how can we track 500,000 orbits? This is one method. It's called the occultation method. An occultation is very simple. It's when a star is there shining in the sky and an asteroid is orbiting and suddenly it gets in front of the star and it blocks the light from the star. So for a split second, the star disappears in the sky and then the asteroid continues and the star appears again. So imagine we built 100 telescopes in a straight line and all of them are automatically 24 hours per day, 7 days per week, pointing at stars. Stars that we know are close to these asteroids. And they're trying to see if the stars are gonna disappear for a while and appear again. At the exact moment where a star disappears, the telescope registers the time. And at that exact time, we can pinpoint the asteroid because we know it was exactly on a straight line between that telescope and the star. Now, if we did this, we predict that we would get at least 5 occultations events for each of these 500,000 objects, which would be enough to get a really good idea of the timing of these orbits and also if these orbits are displaced or not. So, Planet X, you're running out of places to hide. We'll soon find you. Now, what does this mean in terms of the whole project of humanity trying to map the whole solar system? You see, we know our immediate neighborhood really well. We've been tracking it since ancient times with our eyes, then with the invention of the telescope, with telescopes, and nowadays even sending probes to space. But this is our immediate neighborhood. As for the outskirts, the vast regions in the depths of the solar system, we need to do better. If we're gonna settle the debate about how many planets exist in our solar system and whether Planet X actually exists, we need to use Planet X's own weapon against it. And this weapon is the force of gravity. Thank you all for your attention.